Hello everyone, welcome to this session in which we are going to discuss Matplotlib in Python. Let's wait a couple of more minutes for everyone to join and then I'll begin the session. I think by now everyone must have joined the class, so let's begin. So today, as I just mentioned, we are going to be covering the topic of Matplotlib. Matplotlib is a library in Python which helps us to create many graphs like pie charts, line plots, scatter plots, and bar graphs. And we are going to be covering some of them in this session. And I hope that after this session you know the basics of Matplotlib and can draw a couple of graphs by yourself. Okay, so let's begin. So first thing first, we need to import the Matplotlib library, and we would need to import Numpy for some of our basic array creations. Now let us first see how is the Matplotlib library defined, right? So as you can see, it says here matplotlib.pyplot is a state based interference to Matplotlib, and it provides a MATLAB like way of plotting. So MATLAB is another let's say software which is often used by machine learning people and people who want to basically get a visual interference of inference of what their data looks like. So Matplotlib takes some similarities from that particular software, and it can plot graphs in a very similar manner. So it is basically intended for interactive plots and simple cases of programmatic plot generation. So in this case also they've given an example that there would be an x variable which would be a numpy array, and then a y variable which would depict what the y values be corresponding to those x values, and then you would plot that array. Anyhow, let's begin. So let's first start by plotting a simple numpy array. Assuming this is a numpy array, let's make it a bit more complicated than this. So assuming it is something like this, right? So if I now use the plt.plot function, right? So this function plt.plot is used to basically draw a line plot. What is a line plot? We'll get to know. And if I run this particular code, so it gives me this plot. Okay, now one very important thing to mention here is that we've only given one variable, right? We haven't given any specifically defined xy variable. So then what is the graph depicting if we have only given one variable? So as you can see, these values, this x np array that we've given, would constitute as the y variable. Okay, so as you can see 10, then 7, then 4, 5, 9, and then finally 11. Right, these are the values on the y-axis, and we can see that they have been plotted. However, what are the values on the X array? So if not specified, the values on the X axis would be the index of that particular element of the array, right? So at 0th index the value is 10, right? Let me just erase this and explain it to you from the beginning. So at 0th index the value is 10, at first index the value is 7, at second index 4, so on, and if you go on plotting like this, so this is the graph that you will get. Okay, so if not specified, then index values will be taken up on the x-axis and the given array would be taken up on the y-axis. Okay, however, this plot that is being shown to you is a functionality of the Jupyter notebook, right? You can because we are plotting this plot on Jupyter notebook, so we can see the entire graph. However, plt.plot just creates an object of the Matplotlib library, right? So an object has been created. However, if I want to actually view the graph, then I'll use plt.show function. Okay, so now the entire graph would be shown to me and it would not just be an object. Now if for example I have to give a y variable as well, so I would let's say create a y variable, and the x variable would remain same, and if I now draw x and y and I specify that x is being given as x and y is being given as y, and then if I show the plot, I'm okay, by mistake I've added another element in the y variable, so there is a dimensional mismatch. So 4, 5, 6 elements here, 6 elements there. Yeah, now I think if I run this code, so you can see this graph on the x-axis we have values from 10 to 11, right? We have values from 4 to 11, 4 being the minimum value and 11 being the maximum value. Similarly, on the y-axis we have 4 being the minimum value and 9 being the maximum value. You can check to every point that the values are being corresponded correctly, and yeah, that's pretty much the functioning of plt.plot function. Now let's understand the functionality of plt.show function. What exactly does plt.show function do? Okay, so now imagine I have one array, that is this, let's call this x1, and another array, let's call this x2, and the elements that we would fill in this would be as follows, right? So now if I plot only x1, right, this is the graph that I would get. However, now if I also plot x2 and I use only one plt.show function for both these graphs, then both these graphs would be shown in a single graph. Both these plots would be shown in a single graph, okay, like this. Okay, however, if I use different plt.show functions for both these plots, then you would see that one graph is being plotted, it ends, and then the second graph is plotted, right? So what exactly does the show function do? So the show function here ends all the graphs before it, right? So let's say there is one plot before it, maybe two plots before it, n number of plots are before it, and once I write plt.show, then all those plots would be incorporated into one single graph. Okay, so let's say rather than just two plots, I have another array x3, and that array is something like this, and then I plot x3 also, and then I use the plt.show function only once. So now you can see three different plots are being incorporated into one single graph only. Okay, now let's see how we can take this particular functionality of Matplotlib to our advantage. So now we have an array, and I want to plot x square, that is squared of every value, on the y variable. So it would give me some result like this. However, in this very same graph, I can also plot the x cube of the x array. So you can see how exponentially the values are rising. So what's the difference between x square and x cube? Okay, you can even plot x to the power 4 also if you want. Yeah, so something like this, right? Now, assuming you want to, let's say, plot sine of x. So we have x, and we'll arrange values, and if we have to plot the sine of the x variable, so as you can see, this is how the sine curve looks, right? So as some of you might remember, the graph of a sine wave is like this, and the graph of a cosine wave is something like this, right? Pardon my drawing, I'm not really good at it, but I hope you get the idea. So similarly, instead of sine, we can also plot cosine, right? So you get this graph. And by now I hope you have a basic idea. One very important thing that you can see, that the graph on the y value lies between 1 and -1, which is how the cosine and sine function basically works. And in the same plot, you can also plot x and sine of x, and x and cosine of x. So you can see how these plots are being formed. Okay, now take for example that we have just made a line plot. What is a line plot? Line plot is something like this, right? So this figure is known as a line plot. Okay, now we do not want a line. In the next plot that we are about to draw, we do not want a line. What we do want is, let's say we have a graph like this, and we want different points plotted on the graph, right? Maybe at a later point we'd want that we can join these points and then get a line plot as well, but for starters we would want to have our points, right? So this particular function is done, this particular result can be obtained by the scatter function, right? So scatter function basically plots the points, not the line but the points. Oh sorry, I didn't put a y value, I need to create and if I now run this cell, so you can see that we have points with us, right? I can change the y value also to my wishes, and this is a plot that I get, right? However, one very important thing to note in a scatter plot is, we'll call this scatter plot. So one very important thing to know in the scatter plot is that you have to give both the x and the y arguments. So you have to give x and then you have to give y, right? In plt.plot you only had to give the x argument. You could give the y argument as well, but if y argument of if any one of the argument was not given, it was assumed that the argument that you are giving would be taken up on the y-axis, and the index would form, index of the array would be formed as the x-axis. However, this is not possible in scatter. In scatter function, you have to give both the x array and the y array. Okay, so now let's say that I want to draw a line. Let's just create a scatter plot first. So y array would go something like and so let me just check that all the elements, the number of elements in both the arrays are equal. So we have 7 elements here, and then we have 3 to 5 8 elements here. So yeah, this is the scatter plot that I am getting. Now if I want to draw a line plot also, right, if I want to draw a line plot through the points that I have, then I will use the plt.plot function, and now I have a line through my points as well. Okay, so you can use both the scatter function and the plt.plot function together to get this kind of figure. Okay, now another thing here to note is that what if I want my plots, the line plots color different from the color of the points? Okay, so then there is a functionality that is called color. Okay, so assuming I want my points to be red colored, so I'd pass in the color red, and if I run this code, so you'd see that the points here are of red color and the line plot is by default blue only. If I want my line plot to be green, I'd pass in green color, and you'd see red points just like before, and then green line plots. Okay, now what if you do not want circular points, right? There is a high possibility that you do not want your points to be circular, you want them to be triangle or maybe an asterisk, right? Then Matplotlib has a functionality for that as well, that is known as marker. and marker I can pass this. This symbol is basically used to represent exponential. I can use this as a marker, and now you would see that my markers have been changed from round dots to triangular objects. I can even change my marker to an asterisk sign, and then star would be my points rather than the default round circular points. Okay. However, one very important thing to note is that you cannot just put whatever you want as a marker. I cannot put let's say some random string as a marker. So if I want geeks to be my marker, so it will throw an error, right? So what exactly can be put as a marker? A list is available on the matplotlib.org website, and you can check that up, and then you can create your plots in whichever manner you want them to. A couple of other functions. Let's just take this and make a line plot, and then I will show you what those other functions are. So now imagine you want to put a title to this graph, right? So you would use the function plot.title, and you want to name this random graph. So as you can see, the title will appear on the top of the graph. You want that the x and the y axis should have a particular name. So the function you would use is plt.x label for the x axis and plt.y label for the y axis. So x axis values and plt.y label, y axis values, and as you can see, we have our string printed out in the x axis and the y axis respectively. Okay. Now one more thing is deciphering the notations on the x axis and the y axis, right? So right now your x axis looks something like 2, 4, 6, 8, 10, 12, right? Now you want all these numbers to be rotated. Okay. What is rotated? Basically, to edit the values that are written on the x axis, we use the function plt.xticks. So if I type in rotation is equal to 90, so now you would see that my numbers are rotated by 90 degree anti-clockwise. Okay. If I type rotation is equal to 180, so then they'll be rotated 180 degrees. Okay. This is just to make your graphs look more attractive, and probably you would not need it on a very daily basis, but it's just some information that might help you. And similarly, we have plt.yticks, and rotation is equal to 90, so the values on the y axis would also be rotated by 90 degrees. Okay. And yeah, one last thing, if you want to increase the font size of whatever is the title of your graph, then you would pass the parameter font size, and let's say font size is equal to 10. Okay. So now see this value, and if I increase the value, let's say 20, then the value of the font size of the title of the graph, it increases. Okay. Similarly, if you want to change the value of the x axis, this particular string, x axis values and y axis values, you would pass a parameter font size, and font size equal to 20. So x axis values size increases. Similarly, if you want to increase the size of the y axis values, so font size 20. Okay, so I hope you have a basic idea of how to play with your graphs, and we'll just do one more function with line plots, and I am going to take this as my array. So if I plot the squared value of the graph along with the cubed value of the graph, and if I show the graph, then these are two plots that would be incorporated in the same graph, right? We've done this, nothing new, but one important thing to note here is that let's say you're using this graph, or you want to create this graph for a meeting, right? So you want to depict that this particular line, that is let's say the golden color line, represents something, and then this blue line represents something else, right? So the blue line can probably depict COVID cases per month in 2020, right? So these can be your months, and so 12 would be December and 10th October and so on, and this can be probably COVID cases in 2021, right? Just as an example. So then how would you donate it? How would you denote it, right? So there's a function for that as well. You pass a parameter called label, and you label the squared one as cases in 2020, and the cubed one as cases in 2021, and you would have to pass the function plt.legend. So any information about the graph is known as a legend. So you pass plt.legend, and if I run this code, so it shows that the blue line depicts cases in 2020, and the orange goldenish line represents cases in 2021. If you want to change the color, let's say I want 2020 to be red, and I want 2021 to be black. So this is what I will be doing. Okay, so we'll put in the title plt.title COVID cases, and that would appear on my graph. Okay, so I think we've done enough experimentation in line plots and scatter plots. So now we would be moving on to a different kind of plot that is known as a bar plot. What are bar plots? Let me just explain to you. So this is your graph. These are some y values, right? So 10, 20, 30, 40, 50 and 60, so on. And this is, let's say, the range of marks of students. Okay, so this is, let's say, let's mark it as percentage. So 40%, 50%, 60% and 70%, right? So 40 students in a college have scored 40% marks. 50 students in college have obtained 60% marks. 60 again 40, and 70% marks have been obtained only by 10 students. Okay, so this is your percentage marks and this is your count, right? So this is what your bar plot would look like. Let's plot it in Matplotlib so that we can get a better idea of how it functions. So percent marks, let's define an NP array. So percent marks, so percent marks would be 40, 50, 60, 70, 80 and 90, let's say an even 100. Okay, and then your number students would be another NP array, that would be 10, 20, 30, 40, 50 and 60. Okay, now I'll use the plt.bar function, and the basic idea remains the same in all Matplotlib functions. Okay, so anything that I am drawing, let's say it is plt.plot, right, or dot scatter, and in this scenario dot bar, values would be put in an xy fashion. Okay, so the x value would go first, followed by the y value. Plot is the only function in which you can skip the y value. You can just put in one array and the other would be assumed as the index. Okay, so in plt.bar I type percent marks and number of students, and if I show this, okay, I need to put in one more value, and now you can see that this is the graph, this is the bar graph I am getting. So same title function remains the same. plt.title would be random data, and there are a couple of functions in this bar plt.bar function that we are going to explore. One of them is width. Okay, width. So how does width play an important part? So if I type width is equal to 0.25, and now if I type width is 0.5, so the width of each bar increases and decreases on the basis of the width parameter. Okay, now rather than putting in values of such hundreds, let's make another variable. X1 is equal to and x1 is a numpy array, and y is also a numpy array, and if I now plot this, so x1 comma y, and this is my bar plot. If I change the width of the bars change. Okay, now let's try one more thing. Let's try plotting two plots in single graph like we did in line plot. So I name another variable, that is x2, which is a numpy array containing 6 elements, and the 6 elements would be 4, 5, 6, 7, 2 and 10. Okay, and now I plot x2 with y. Okay, so now as you can see, the graph has become a little messy. So what exactly is being done here? How is Matplotlib functioning in this manner? So basically what happens is, if you have a bar graph, right, and let's say you have a bar graph like this, okay, and then you are drawing another graph over it, so the graph would be superimposed. So at this x value, if the y value is greater of the second graph, so the graph would superimpose over the original graph. At this x value, if the y value is lower, so the graph would remain below. So this is exactly what is happening in this scenario. Okay, if I type in width is equal to 0.5 as in the blue graph, so you would see the exact superimposition being taken place, right? So now how do I remove this superimposition? I want two separate graphs. So what I would do is that in this scenario, I would move this purple graph little to the right. Okay, so rather than having two graphs over each other, it would become one graph like this, and then another graph like this. Okay, so you would get two graphs side by side. Let's say I want to move the second graph. Okay, second graph would be the orange graph. So I have moved it by 0.25, and as you can see, the values shift. Okay, if I move it by further, let's say 0.5, so things become bit more clear. I decrease the width to 0.25, let's say, and now my graph is much more clearer than what I had before. Okay, so you can have two graphs coexist also by playing with the x variable and the width variable. Like in the line plot, the color function remains same. Color, if I type in red, then the graph will become red. If I type in color violet, let's try violet, and this is my result. Okay, now we would move on to another kind of graph that is known as pie graph. So what exactly is a pie graph? Some people like to call it pie chart as well, and it makes absolutely no difference. You are free to call it whatever you like. So basically, a pie graph or a pie chart is a graph that is represented in the form of a circle. And let's say you are to check in an office what percentage of employees are vegetarian, vegan, and non-vegetarian, and have only egg, right? So there are four hierarchies of what different people like to eat. In such a scenario, your pie chart would look something like this. Right? So this area is probably taken by people who eat non-veg. This area would be taken by people who are vegan. This area would be taken by people who eat only egg, and this area would be taken by people who are vegetarians. Okay, so now I hope this basically gives you a fair idea of what a pie chart is supposed to look like. Okay, represented in the form of circles and ratios, percentages, ratios, whatever you like to call it. So now let's draw a pie graph, and see, in a pie graph you don't have any x and y values. you have only one value that would form the ratio of your pie graph, and then the other one would form the label. Okay, so let's say I have my values. We have the same exact question that let's say 25% people in the office are non-vegetarian, 35 are vegetarian, 10 are vegan, and how much is left? So 25 plus 35 gives us 60, so, and the rest 30% are people who consume only egg. Now labels would be non-veg, vegetarian, vegan, and egg. Okay, so I'd use the plt.py function. I'd pass in the values and the labels, and if I show this plot, this is what I get. Okay, now let's try to mess with our graph and beautify it furthermore. So first things first, plt.title food consumers in an office. Okay, title function has remained constant throughout the entire Matplotlib library. That is not going to change. Same label size can also be used here. Let's say I want the label size to be sorry, not the label size, font size. Yeah, so font size can be used here also, but let's just focus on the graph for now. Let's try to beautify the graph furthermore. Okay, so there is one particular parameter that is known as shadow. So if I pass in shadow and I shadow parameter, I set the shadow parameter as true, so you would see some amount of small outline that would be the basis of our shadow is added in this pie chart. Okay, so shadow is added in the pie chart if I set the parameter of shadow to be true. Then let's say I want one particular label to explode out of the entire circle, right? So what does explode basically mean? So in this scenario, I want this vegetarian group of people to kind of come out of the graph a little bit, so that it gives you an idea that the graph is more beautiful. So oops, I closed the notebook by mistake. Just a second. Yeah, so now I want to remove one portion away from the graph just to make it look a bit better than it is. So I'd pass the explode parameter, and explode parameter takes in a tuple. Tuple would be 1, 0, 0, 0, and I'll explain it to you later. Let me just pass it on right now. So yeah, as you can see, if I want to explode the vegetarian group of people, so I'd use this. Okay, I do not want it to explode as much as this has, so I'd just use 0.5. Okay, so the vegetarian group, the vegetarian section has removed itself from the circle, and it looks a bit better if you're trying to focus on one particular group. Okay, now let's say I want to increase this. Before that, let me explain to you what does the explode function does. Okay, so explode function would take a tuple. Okay, now what would be the values of that tuple? The values of the tuple would mean how much you want each particular section to get away from the graph. Okay, and what would be the order of the tuple, the order of the tuple would be same to the order of the labels. Okay, so now let's say, like in this case, I have put the values as 0, 0.5, 0 and 0. So that means non-veg, the value corresponding to non-veg is 0. That means I don't want my non-veg section to leave the pie chart. Okay, next is vegetarian. Vegetarian is 0.5. I want my vegetarian section to leave the circle by 0.5. Vegan 0, I do not want it to leave the circle. Egg also 0, also don't want it to leave the circle. Okay, so this is what the explode function does. I can even explode all the values from the circle a little bit. So if my tuple looks something like this, then you would see all the values are basically forming a part of one jigsaw puzzle rather than being part of a pie chart. Okay, now if I want to increase the size of my circle, right, let's just put only one explode here right now. Okay, now I want to increase the size of my pie chart, so I would pass in the parameter radius, and let's say I want my radius to be 1. Okay, so this is my radius 1 pie chart. I want my radius to be 5, pretty big, right? Let's just keep it at 2, not even 2, 1. Okay, looks pretty nice in this manner. Point being, you can increase the radius as much as you want to. Okay, let's just go over one last functionality of the pie chart, that is, assuming you want it written in the pie chart, what is the percentage of values, right? You want it written that non-veg people constitute 25% and vegetarians constitute 35% and vegans constitute 10% and the eggetarians, as they like to call themselves, constitute, I'll just write it here, 30% of the total population of the office, right? I want it written here. So there is one added functionality for that goes by the name auto PCT, and you pass a string and the format of the string is, so in auto PCT the format of the string would be 2 ampersand signs, and here you will describe how many decimal places you want your percentage values to have. Okay, so there are 3 ampersand signs, and in between this I write 1.2f. so 1.2f means that there should be 2 decimal places in my percentages that are being written. If I run this code, so you'll see that 25%, 30%, 10% and 35%. If I write 1.1f, so only extra 1 decimal place would be added. Okay, so I hope now you have some basic idea about pie charts as well. One final thing that I want you to know is that the values in this array or in this list need not sum up to 100. Okay, so if I change the egg value to 40, okay, so now the total percentage becomes 110, right? The sum is not 100. So you do not need to worry about that. Matplotlib can take care of that by itself. You do not need to check if the value sums up to 100 or not. If I run this code also, my graph would be made in just the manner I want it to, and no issues would come on the basis that the sum of the values is not equivalent to 100. Okay, the percentages would be adjusted accordingly by Matplotlib. Okay, so in today's session, let's do a quick recap. We've done how to create a line plot. We have seen how to create many line plots in one single graph. We've seen how to make line plots using different sine functions, cosine functions, the quadratic function and the cubic function. We've seen how to make a scatter plot. We've seen how to make a scatter plot along with a line plot. Then we've seen how to change the values on the x-axis, the y-axis, the title of the graph, the size of the title, and we've seen the usage of the legend function, which basically tells us about different line plots in a single graph. Then we've seen about the bar graph, and finally we've seen how to create a pie graph. And I sincerely hope that you were able to grasp what all was being taught in the class today. If there are any doubts, I recommend you to please post them in the comment section, and I'll get back to you as soon as I can. Thank you.